Hi, I'm Tim. I'm basically the Tim from the Tim videos, and Tim videos is what we're using to do LCA streaming this year. We've used it in Ballarat, I think, as well, and we've also used it for PyCon in the US the last 2 years. And this is my experiences with it and how it fits together and those type of things. Back in Ballarat, I actually gave a talk at the main conference called Making Video Streaming Interactive, and it kind of goes through some of the ideas I've had about how to try and make a conference where the people who are viewing the streams aren't second-class citizens. They're people who can be part of the conference and actually enjoy and attend. So if you want to have a look at that, you can go to that YouTube video. I'll also share the slides later, so you can interactively click on a link rather than trying to copy down that URL. You'll also, at the end of that, see the first iteration of my portable system, which the second iteration is sitting there, which if we have enough time, we may not, then I'll also show that around. So kind of why do live streaming, I guess, is the first question you have to answer. Like in Australia, lots of people are actually remote. Australia's this huge country with only like 20 million, 25 million, almost 30 maybe now, I don't know, 28 people. Most of us live in that small slither of coast, but there are plenty of people who don't. And even if you live in, Perth, you're not on the other side of the country. It's a pretty big place. So having access to video streams means that you can attend things like LCA and things like user groups. This isn't, the stuff I'm doing isn't just for conferences, it's targeted conferences, but I hope to also enable user groups. So my goal eventually is to have every user group, no matter whether it's a 5-person user group or a 100-person user group, to be successfully live streamed and have people attending. The other thing, though, the other thing is that even if you're at the conference, the live stream is useful because I found it's the best way to get good videos. And you're all sitting here at the multimedia mini-conf. There are 5 other mini-confs going on at this very moment, and you can't be in 5 places at once. So getting good quality videos of the other talks means that if there's one that you can't go to because you're here listening to me instead, you can actually watch that. And having a live streaming means you generally have people watching the stream complaining when things go wrong. And this means that you can fix them. You can't fix things post, like if you didn't have any audio, you can't go back in time and add the audio again. So having live streaming gets you much better quality videos and is kind of a QA system. So that's the other big reason I'm really interested in live streaming. So what is Tim's video? Currently it's 3 projects, but they're kind of unified by one goal. And the goal kind of statement is that we want everyone to have the ability to record and host both, record presentations and host live remote participants in a thing. That's no matter, as I said, whether you're a 5-person user group or a massive conference which has 600 people coming to it. So what I'm trying to do is take things where there isn't a solution that currently exists or doesn't provide the right type of stuff and work in that area. So the first thing is a video capture device. I'll talk about that more. The next thing is video mixing, which is basically taking multiple video streams and mixing them together and doing a few other interesting things there. And then the last thing is actually the streaming side, which is providing a website people can go to and actually view the videos on and understand what's going on. Because there's there are video streaming sites out there like Ustream or Justin TV or YouTube or any of those type of sites. But they don't really give you a conference feel, right? If you're watching, say, a couple hours of conference, you want to know what's on now, what's coming up next, those type of things, like the program integrated into your experience. You don't want to have, the other page that you're always flipping through, and you want to be able to see what's going on in other rooms and all that type of thing. And the streaming system is also where you can help bring the other people into the room by integrating things like Twitter and the IRC channels that we integrate and things like that. So this is a diagram I'll keep referring back to and kind of shows how you do an event like this. You have a venue, and in the venue you probably have some type of presenter presenting off a laptop, and you have a camera up the back like those guys up there. And then you have some type of mixing, which again is in those guys up there. And then you shift it off to the internet somewhere, and there's a server there, and then that server takes it and ships it off to the remote viewers. So that's kind of the setup of what you do. So the streaming system is basically this part here. The part that is the remote server and lets the remote viewers view. So it's basically uses a system called FluMotion. FluMotion's quite old now and it's starting to show its age, but I've yet to find anything which is a good replacement. And the one thing that FluMotion has that so many other systems don't have is that when one part crashes, it doesn't take out the whole system. And that's really important because with these systems, even these days, you need to stream in multiple different formats. And if the Flash encoder dies, you don't want it taking out your Chrome users at the same time. And having FluMotion has each thing as a separate process. So when one dies, it can be successfully restarted and it doesn't take out the whole system. So that's why I use FluMotion. This is what the website looks like. This is streaming PyCon. So you can see that at the top, you've got the rooms and then you've got kind of what's going on. I took this obviously during the poster session, which is across all rooms. And then you've got like preview of the videos, and then you've got like chat, and you can see somebody here was excited by Van Rossum or something, and you've got like the Twitter feed, and if you have sponsors, you have sponsors. So this is kind of a much nicer way to view a conference and the streams, like compared to something like YouTube. It still needs a lot of work. As you can see, this year, if you go and look at it right now at timvideos.us, you'll see it looks exactly the same, and that's because nobody got around to theming it for LCA. So if you're a remote viewer and you click on one of those links, this is what the type of thing you get. At the top, you see you have what's coming, what you're watching. Down the bottom, which is kind of cut off, it'll tell you what's coming up next. You've got your video, then you've got this IRC chat, which is just the Freenode web IRC, so you can log on and chat to other people about how it's going. And then you've got like Twitter down the front. And because video on the web is still a bit funny, you've got options like whether to use Flash or HTML5, whether to use HD on or off, those type of things. So there you can see all the different bits. The one thing, though, is that when people are at the conference, you normally have some type of wireless network. This tends to mean that people will go and try and watch a stream for another room while sitting in this room. This is really bad because video is really intensive and it crushes the network. So if you're in the room at the conference, on the conference network, you'll get this interface instead, which tells you some instructions and what's on and Twitter and chat, but doesn't let you access the video because you're at the conference. You should be watching what you're at instead. So yeah, as I said, it connects Twitter, IRC, that type of thing. It's pretty much all in Python. Yeah. The thing that's really important though with getting good quality captures is that you want to capture directly from the laptop. Pointing a camera at a projector screen is a horrible idea for so many reasons. Cameras aren't designed to be pointed at something like a projector screen because they're lit. There's frequency issues, like the capture rate of the camera might be different to the projector capture rate. So if you're playing any time of movement, you'll get lines running up and down the video. It's just a horrible idea. Don't do that. The problem is that the best solution was this thing called a twin pack, which was a VGA capture device, which is here. They don't make them anymore, so it makes them impossible to get. As well, the world's kind of moved on from VGA or is getting there, so you can't use a twin pack to capture HDMI. As well, because it's a closed proprietary system, there's you've got no control over it in any useful way. So I'm working on this project called a HDMI to USB. It's a capture device which takes in HDMI and basically appears as a UVC webcam. So you plug it in and it looks like a webcam, except instead of getting a like a picture, you get whatever's on the laptop through it. And where it sits is, you can see this part here. Because it uses HDMI, it can also do the camera capture stuff. So we're working on an actual piece of hardware, but for the meantime, we're using this thing called a Digital Aligned Atlas prototyping board. So this is the way, if you wanted tomorrow to play with this device, you buy one of these and load our firmware onto it. So the device has 2 HDMI inputs and 2 HDMI outputs, so you could have multiple things captured with one board. It's about $400 if you're not a student, about $219 if you are a student, and that's kind of some of the specs of it. The resolution it does is 720p or 1024 by 768. Raw frames, it does 5 to 6 frames per second. That is limited by the USB bus. The USB bus only goes 480 megabits per second at like the most. This is what, you just can't ship raw frames, there's too many bits. MJPEG, we currently do 15 to 18 frames per second. That isn't a limitation of the hardware. We could quite easily do 25 to 30 frames per second on the USB bandwidth, fine. We just need to fix our JPEG encoder, which we haven't done. And that's just a firmware download and it would fix that problem. As I said, we just don't have time to do that. So this would give you full 720p capture at 25 or 30 frames per second. We're implementing a custom version of this, which removes all the stuff we don't need. It'll come in like consumer and basic model and a conference model, and you can kind of see the difference we're targeting. We're targeting one. This one here is designed to be as cheap as possible. It'll probably be $200 to start with, but we want to get it under $100 so anybody can buy one of these boards. The conference model is a bit more fancy and has things like it uses DVI ports rather than HDMI, so you can screw the cables in so that they don't come out and things like that. And things like has RS-323 ports on them, so you can connect it to a pan, tilt, and zoom camera or something like that. It also uses has an extension port on the side, so you can add extension boards to it. So if you look at the original Digiliant thing, there's this VHDC connector. We'll have the same type of thing on our, the more expensive thing. That connector is really expensive. It's like $20. Anyway, that will allow us then to, we've got a board which does VGA capture. So for a long time, we're going to still need to have VGA support because lots of things won't do HDMI for a while. This will allow us to use the same system for that. And this is where there's really kind of a hole in the market. As Mark was kind of saying early on, there's the Epiphian devices, which are really expensive. There's some more cheaper devices that Blackmagic do, but they have closed source drivers, and you can't use them with like a Video for Linux device, and they're quite hard to set up. Those type of things, there's no open source way to get a video feed of your this, and that's what we're really trying to solve here. Other things like, there's small advantages of using it. When you plug in your laptop to the system, it only advertises one video resolution. This is really, really important because it means that nobody has to say, what video resolution should I set my monitor to? Because there's only one there. That type of small thing is something you can do with a piece of open source hardware that you can't do with a piece of commercial software because you don't have any control over the firmware of the device. And for example, also provides a virtual serial port which lets you check the status of the things, like does it see a HDMI cable plugged into the device? That's a really interesting question to ask because some cables don't actually work. So having that type of thing is really useful. So that's why I think this is such an important part of the future. We're also, because the commercial version is a while off, I've also been working on a case. So you can see here, this is a Digiliant board in a case so that, if you put this in a room, somebody steps on it, it doesn't destroy your PCB board. And that's just made out of acrylic and is designed to be either laser cut or milled out of your acrylic, so anybody can make one of these cases. Just another thing, it turns out that unlike VGA, where we have one standard connector, there are a bazillion different digital connectors, like there's DisplayPort, micro DisplayPort, a bunch of Mac ones. If you ever have to deal with it, this document lists all the ones we know of and what type of adapter you need. Some of the adapters as well, there's a difference between an active adapter and a passive adapter. A passive adapter is just a piece of wire. Not a lot can go wrong in a passive adapter. Active adapter has microchips in it, and there's lots that can go wrong with there. So it gives you a bit more information about what this adapter is going to do to your video signal as well. So I'd highly, if you're doing a conference, take a look at that website, or you're doing this in some way, you can find out what type of adapter you need to get to HDMI. Last project I was talking about is GST switch. This is basically this part of it. It takes the input from the video and mixes it together. So that's the mixer guy back up there. This is what the user interface was. I didn't get time to actually capture some image, screenshots of the user interface because I was writing this slide and been doing video streaming, but it gives you these are the incoming videos and this is what you're projecting, what you're streaming out, and it does a bunch of things like it detects whether there's audio on that stream and whether there's some type of activity on that stream and those type of things. And it all does this in HD, which is something our current solution doesn't do. As well, one of the cool things is that it supports speaker tracking. So you can get a pan, tilt, and zoom camera, like one of these, and you select the face you want to follow, and then if I start going like this, the person up the back doesn't have to adjust the video to follow me. So this is, again, about trying to make it as simple as possible. And it's all powered with a system called GStreamer, which is an awesome framework, which means it's highly extendable. Also has a Python API so that we could write a thing that says, you know, if you detect a speaker dancing around on this video, switch that input, for example, or things like that. A very scriptable API. It also means that other things can control it. So I know the one thing that the LCA guys here have done is that they have a remote control program, which means people up in the NOC can reset stuff down here. That would allow them to control, say, oops, you've put the wrong audio on, we can change it for you rather than having to call down here and say, please switch to audio 1, for example. As you can see, there's a lot going on here, and I could really appreciate help of this. There's a huge amount of different help you could help with, and don't feel like you have to be a multimedia hacker person. I mean, we've got things like documentation that we could really use to be written that is kind of stuck in the head of quite a few people. Your sysadmin, we really need some type of machine management, like somebody could write us some Puppet or Chef or whatever scripts to do that. So there's a lot of different things that we could help. If you're really into hardware and you're really into VHDL, I've been known to send people these boards to get them to develop firmware for them and stuff like that. So, or the PTZ cameras. So if you're into that type of thing, a great way to get one of these boards to play with is to do something for me, and then you'll get one of these boards to play with. And we have a kind of, I have no idea what I'm doing type thing, here's how you can help type thing. So yeah, this is a kind of flow chart. You start at the top and go, I want to work with chips, and I like my hardware real, so you could do like HDMI to extension boards, or I like it fake and virtual, you can do HDMI to USB firmware, or like if you're a web hacker, maybe you want to work on the streaming side, or if you're a Python hacker, you know, there's something there for everyone. I need to update it to add some things like if you're not this is just a software developer one. I need to have one for like, anyway. All the code is on GitHub at Tim's Video. If you're using the streaming site for some reason and you come across a bug, send me a pull request and I'll probably deploy it in the next, half an hour or so. Lastly, how much longer have I got? Okay. As I said in the beginning of the thing, in 2012, I think it was, at Ballarat, I demoed the first iteration of basically taking the setup that these guys have got back at there with, a bunch of laptops and computer cameras and stuff, and a bunch of computers up in the NOC and all that type of thing, into a box that an self-proclaimed non-techie could use. And this is the second iteration of where it is. It's still not quite finished. As you can see, things are still a bit wrapped. But the principle behind this, and it's getting there, but it's not quite there yet, is that on the front of this, and the previous version had this, is that there's instructions that says undo the zip, open the laptop, and press the power button. Thing boots up and it says, please connect the power. And it's got a wizard interface, and it won't let you go to the next page until it detects you've plugged in the power. And it goes through all the setup needed to get a good quality thing. Like it tells you how to mount the microphone on a person with pictures, and then you click OK, test, and it says, please read this. And it tests and auto-adjusts all the audio levels. So it's really designed to make it as simple as possible. And like plugging in it, it tells you how to plug in which ports, and the ports on the front are all color-coded. So it says plug in the presenter's laptop to the green port. And there's only one thing that's remotely green colored. I have to check whether it's color bind compatible though, because I think I use green and red, which wouldn't. And this thing here, all the video is trunked up to the internet via NextG Wi-Fi. So this thing doesn't even need local Wi-Fi at the venue or anything like that. It doesn't need to connect into the sound at all. And it just sits in between your laptop and whatever you're using to projecting, and it's totally transparent to that device. So this is the portable setup. I'd really love help with that. Again, 100 things to do, not enough time. Yeah, so that's a cool little thing. If you want to come and have a look at it, that would be really cool. If you've ever programmed IR codes, we need to figure out some way to replicate this remote using IR toys. If you manage to get it working, I'll quite happily give you an IR toy. And they're a little receiver and IR remote type thing. So yeah, that's kind of what we're doing with the streaming. I wonder if it's still happy or not.
Why does it require PowerPoint, or could you also use any other presentation software?
It doesn't require PowerPoint, the software. It requires a physical PowerPoint in the wall. Because, yeah, it needs... Power socket, yeah, and you need to plug in one of these. So yeah, just to be clear, it requires nothing on the presenter's laptop at all. To the laptop, it looks like you're talking to the projector. To the projector, it looks like you're talking to the laptop. And because this one's a VGA system, because VGA allows you to passively read it, even if this thing stops working, the presentation still goes on. So it's designed to give you the streaming if possible, and if you don't, you still are able to continue with your user group. So yeah, and I would love to get some of these working and actually in use around various locations. So if you've got an active user group, especially in Australia, that is really wanting to do something like this, I'm quite happy to work with you to help you get one of these working, because the biggest part is actually testing these, right? The more you test, the more problems you find. You find that, somebody thinks PowerPoint is a piece of Microsoft software, not something that you plug in. I haven't used PowerPoint in years, so I don't have that association. But there are lots of other things like that. It's really surprising.
So a question on this is, for the HDMI version,
Yep.
how do you get around the device deciding that it doesn't want to send it because it's not, I've got current protection from HDMI?
You don't. Sorry, I'll rephrase that. I don't. But if you were to go on the internet and find out the HDCP master key and generate yourself a HDCP key and then load it into the firmware, there would be no way to tell that it wasn't a real device. But I don't strip it, because we use it at conferences, right?
Laptops, they don't care, is that right?
Yeah, they'll output HDMI or DVI or DisplayPort quite happily until you try and start playing a Blu-ray DVD or Flash or something like that. So yeah, and These are all the things I'm working on, and there's a lot of interesting things you could be working on too if you want to help out. Yes, James?
Accessible. There's been a couple of years we were looking at that, and you were saying that you get about 5 frames a second with the limitation of the USB 2 bus. Are they doing anything around USB 3 that might actually make that easier?
So the Alice board can do RAW at 5 frames per second, as I was saying, at 720p. When you do the MJPEG compression, it reduces it by 70%, the size of the video, which means that you can do the full 720p at 30 frames per second. We just haven't got around to optimizing our VHDL firmware to support that yet.
Slight latencies then into the MJ.
A single frame.